Alrighty, how are you doing? Hopefully you're doing well. Here we go. My slides are coming in. Excellent. Cool. So my name is Aurimas. I'm from Google. I'll be talking a little bit more about effective testing of code on Android devices. And in fact, I actually want to talk about more effective testing on code that will run on Android devices. And why that matters is that we can actually take advantage of the fact that Android runs Java or Kotlin code, and you don't necessarily have to run it on Android. So this is a bit of a joke, but you shouldn't test if you can avoid it. And what I mean by it is, excessive testing doesn't really help. And especially on mobile devices where you have resource constraints, it's even worse. So best practice, if you can avoid it, just don't test. And I know it sounds a little silly coming in a productivity engineering summit to not test, but in fact, I think it is often, the case. If you go and throw a parameterized test that does 10,000 variations or something, you're not necessarily gaining a lot of value. So think about that first. And really what we want to do is we really want to approach it with kind of a minimalist approach. Do the least amount of work you can do to achieve the effect that you want. So specifically, what is the minimal amount of thing that you can do? It's writing your features and projects as a Java or Kotlin pure project, and then testing it on a JVM just to JUnit. And the things you get out of that is that you're able to cache that on most build systems. So, Bazel, Gradle, pretty much anyone will cache that for you so that you get essentially, not repeating the work you already did. It's orders of magnitude faster than Android because JVM, you'll be running on much more powerful processors. You'll have more cores and so on. And it also nudges your code towards more scoping. You will be writing features that are smaller in scope. They're more focused, and so you kind of end up writing more unit test style things as well, which it can be very helpful. Obviously, the downside is that you have to go and separate all of your code out and make it Android only, and that can be really painful. So it's not really doable for legacy code bases or legacy features, but kind of going forward, it might be a good idea to kind of build that in as a practice. Some tips when you do write these is that you can actually run more than one at a time. And in fact, Gradle, for example, provides you a max parallel forks flag for a test task, and you can just say I want X number, or maybe make it dynamic based on the number of processors available and so on, and that way you're running multiple at the same time. And then you can even do distributed testing. So if you have Gradle Enterprise or I guess the Velocity, you can go and throw those tests over to run on a remote machine. So your laptop, that the developer is working on, is not being burned up by the JVM tests that are running. I think the thing that we want to talk about next is Robolectric, which is a framework that is essentially attempting to make it possible to run Android tests on JVM. It is kind of built from Android source code, but with additional fakes to make it possible to run on JVM. This project has Google contributors, but is not an official Google project. So you kind of insert hand waving of what kind of support you're going to get. I believe it's the next kind of best step. It's really a good way to test in a sense that is slower a little bit than the JVM tests because now you're running more code. But in reality, it's still orders of magnitude faster than Android. Still have the same cacheability. You're still, but now you're able to actually run Android-specific things. So you might have a thing that maybe requires a context that you pass in, or maybe has some other thing that you want to pass on. And so you're able to actually exercise some of these bits and pieces. And it actually even lets you do some stuff that you can't even do on a phone. So for example, you can turn off Wi-Fi in the types of fake manager of a network manager where you might not be able to do the same thing because Android, doesn't allow you to do that thing. And then of course the cons that come in that is you're not on an Android device. So you actually might get a false confidence that you're like, oh yeah, my test is amazing. Like we're all done, let's ship it. Reality is you're running on something that is not Android. And that way, you might have that disconnect. As I said, the support is a little shaky because it's not really an official Google product. But many big projects and even internally Google is using it. So I'd say for most part it is a pretty safe usage. Some tips about when you are working on Robolectric is it is a good idea to cache the system image downloads when you're running in CI because those system images are in gigabytes in storage. So if you're fetching it every time, that's going to get very expensive. By default, if you run it through Gradle, you will not cache anything. So, you might want to think about that. The other thing to do is actually you want to minimize the Android usage anyway, even in this case, because you are working with fakes. And, the least you depend on that, the more accurate and more kind of focused you are on your code. And then lastly, in Robolectric 4.10, they launched support for native graphics. That is opt-in feature. That actually even allows you to render using Skia and like the stuff that Android would actually use to render. And it gives you much higher fidelity of the stuff you might want to do. Of course, use it sparingly. It's a lot slower. And Windows support is shaky. So if you have a lot of Windows developers, that might not also be a great idea. The next best thing in my mind is writing tests that don't use activities. What I mean by that is most examples out there for writing Android tests will throw you like, here's an activity scenario. Here's you launch it, you do whatever. But often you don't actually need an activity to test the thing you're testing. So if you're only, exercising something and it either needs a resource, you can easily use application context and pass that resource into your test. And that way you're avoiding 100 milliseconds cost per method of launching these activities. So if you're able to do that, that's, way better. You're getting real Android behavior here because you're running on the real thing. And then you're kind of isolating yourself from flakiness of activity launches, throttling, anything like that. The huge downside of this one, I would say, is that by default, you're not going to get any caching unless you're using Gradle managed devices, or if you have some sort of custom solution that will do that for you. And then sharding is also complicated because Android really only runs one thing at a time. And so if you want to shard your tests on multiple kind of concurrent runs, you have to have multiple devices. And that's, gets really expensive. If you're running emulators, you can only run, so many until you run out of RAM and you're not, not able to do anything else. And then, of course, there's a lot of flakiness due to device instability. OS, especially in the older versions of Android, which is often what you kind of want to test on, is really unstable. So you will be running the tests, and as the test runs in the background, there might be some random process that goes and nukes you down, which is really unfortunate. And then finally, kind of like the least exciting solution, but you can do is actually run it. The activities do like the real thing. And then you're testing the real Android behavior. You're kind of getting pretty high confidence that you're doing the thing that your end users will be doing. Downside is really slow. Like we're talking hundreds of milliseconds at minimum just to launch the activity. And so you really kind of want to be careful of that. And you have the same problems of lack of caching, sharding, and then flakiness gets even worse because now you're running for a longer amount of time. So the way I like to think about it is kind of like there's a pyramid between like fidelity and performance. And you really want to kind of have your base heavy on running stuff on JVM using JUnit because that gives you a very quick iterative way of getting, signal. Like, did you make a change that broke your code base? And then slowly kind of build up as you go. And, at the end, you have kind of like UI tests that are, giving you like the actual, what will happen on a device, but you have way fewer of them. And in fact, to make my point even more clear, what I mean is what you want to do is this, which is you want to write even fewer tests that run on Android and then focus on everything else to be covered by stuff that runs on a JVM. That way you're, avoiding all these problems. So kind of carrying on that, I mentioned the stability is really highly important, especially as you get into the activity-based tests. You're going to be running for minutes at a time. And, Android will go and crash in the background. There will be GMS core update that happens. There's all sorts of ways that it will go bad. And so the stability is even more important. And flakiness gets kind of magnified because now a cost of retrying is even higher because, if a test flakes and it takes 5 minutes to run, now you're spending 5 minutes deflaking that test. So aggressive deleting and disabling of tests is kind of vital to keep your health of tests. And I think it's true for JVM, but it's even more true for Android. I think the other thing to be careful about is cleaning up after your tests. If you have a test that goes and rotates the device screen and your test crashes or fails, don't leave the test in that state where device now is rotated in landscape or portrait, and you got to reset. And then finally, if you're able to between CI tasks to reset these devices, in emulator, it's pretty easy to just use snapshots and reset the snapshots. On the physical devices, you probably want to do a factory reset or use a custom profile. And that will give you, even more isolation, and so you don't have these collateral issues. So if you do decide to jump on this journey of writing on a device, which, I've been discouraging you from doing so you enter that. What you really want to do is you only want to run what you need. And what I mean by that is you really should avoid running Google system images if you can for emulators or physical devices. and run on AOSP images. And what that gives you is a much greater isolation. Like if you don't need Google Play services, just run on AOSP and you have way fewer processes, way fewer things running in the background. It just gives you a lot more stability. For us, when we enabled AOSP testing instead of testing of Google images, we gained around 15% of on-device test time, like performance gains. So it's pretty big. And then even better, you can even disable some things that you might not need, like maybe a launcher is not helping you and doing work in the background or something else. And then kind of like the next step forward is using automated test devices images that you have now available for emulators that actually comes pre-stripped, and all of these packages are just removed, so you don't have to worry about disabling anything. And then as you do a lot of this modularization, you probably seen, in a lot of talks, people are talking about like, oh, you should have your modules, many of them, do smaller things, easier to test, all of that. And if you do that and you split your tests the same way, you get the benefit that, now you have these more discrete chunks of tests as well that you can do, which allows you to have like less interference and so on. So you just kind of keep that practice as you break your code, also break down your tests into smaller things. Kind of to give you a little bit of motivation, I wanted to share a little bit of what the AndroidX case study looks like what have we done and like where are we? So if you attended my talk last year, I kind of talked about how we kept our build speeds at bay. And you kind of see that it's actually in a pretty good spot, right? Like, it was trending a little upwards. We kind of did a pretty good job of caching, making sure we improve our builds, all of that. I feel like we're in a good spot where I'm like not panicking about this anymore. But test time was not looking like that, right? Like it was steadily growing and you can't really see the numbers that well. But it was getting to the point where it was getting to like 80 minutes on average of device test time, which is a prohibitively expensive thing to run on. And so people on the team were growing to be unhappy, obviously, that's where they're spending time. My slide disappeared. Here we go. The key insight of one of my coworkers is that similarly, in the way that tests are cached for JVM tests, is that if the binary jar has not changed, the test results will be identical. Same is similarly true for Android. So if the APKs, the packages that we're shipping are not changing and the device is kept constant, the test results will stay the same. So kind of like you can exploit that and use as a way to save yourself time. And when you combine that with modularization, and if you have smaller and smaller modules, you'll have more and more APKs that are essentially not changing, and that leads to the ability to skip running tests and then just returning test results from a previous previous run. Sadly, when we tried to do this, we kind of realized that there's all these problems we had that were causing APKs to be unstable. And what I mean by that is if you run a build, nuke the build directories and you build it again, and we actually got different results, that was problematic, right? Like that means you have, unstable builds. For us, one of the things was baseline profile generation. There was a bug in the tool that actually created a new thing because it had this timestamp built in. And of course, that would, cause all of your tests to constantly not hit the cache. Similarly, we had a bug in our code where we were doing some sort of jarring where we're including stuff using a shadow plugin, and we were accidentally including incremental Kotlin compiler metadata, and that was also changing every time you build, and so it was kind of constantly causing the churn, so we fixed that as well. Another thing that we got hit is that in AndroidX, we really want to make sure that the next version of Android platform is compatible with our libraries, but by the time you adopt them, they actually work for you. And to be able to do that, we actually build and then test on devices that are pre-released. So using, Android V for the next version. Surprise, surprise, it's alphabetical. What we do is we build against a different SDK, and there was a metadata that it gets included in each APK that actually tells you which SDK version you compiled against. And what that leads to is that it essentially made APKs differ. And what we had to do is to strip it. And we had a similar bug where changing the SDK version, and because of Android API 34 was including record types, it was also causing an unnecessary diff. So we had to fix that as well. So for us, what we ended up doing is we wanted to move away from our custom solution of the device lab that we had to move to Firebase Test Lab, and specifically adopting the caching based on the stuff that I just discussed. And additionally, we kind of went ahead and took a step further where we actually also wanted to do sharding. Instead of just, taking our tests and splitting on M number of devices, we actually dedicate one device per test APK, essentially. So each module is completely isolated from each other. And this isolation not only makes it more performant because you can now run all of them at the same time, it also gives you isolation. So if one module goes and messes a device and puts it in a bad state, the next test is not affected because it ran on a different device. So to kind of give you motivation, this is what our numbers look like. So, as you were seeing, it was really at P95. So this is the kind of the worst case essentially scenario. We're looking at, running for 3 hours. It's ridiculous at that point, right? Well, a little less than 3 hours, but long time. And then it's essentially half to the time of this, because now we're hitting all these caches all the time. Especially was really helpful for us when we're making changes to our build plugin. Normally build plugin, essentially we had to be safe and run all the tests on the build plugin changes, because you could have nuked the APKs, you could have broken them in any way. But now that we have exactly the APKs, if you're changing or not, we're able to, assert that we didn't break anything. And so we're saving a lot of time. Same ended up being true for meantime. Of course, the drop wasn't as drastic, but we still saved half of the device test time. And at this point, we're about 30 minutes or pre-submit time for, a really massive code base. So it's really great results for us, and they're staying steady on there. So what's next for us? I think the next thing that we want to look at is rework the way FTL does test retries. Currently, it retries the whole shard. And of course, that just could introduce more flakiness because now you're running more tests. So we're moving to a system that will allow us to retry tests per method. So if only a single method failed, retry only that one. Not only you save time, it also reduces flakiness. And the other thing that we ended up doing while we were migrating to Firebase Test Lab, we ended up moving to emulators, and emulators had bugs. Luckily, we sit right next door to the emulator team, so we could go and complain and get stuff fixed. And now we are intending to do the same thing and kind of expanding that and working more on emulator to kind of do more work. So I am down to my conversation. I have a one question worth of time. So if anyone wants to ask one, I'm ready to answer. And if not, you'll find me outside of this talk. All right. Awesome. Thank you.